There is a telescope standing high above the clouds in Chile's Atacama Desert that never truly rests. Night after night, beneath some of the clearest skies on Earth, it opens the largest digital camera ever built for astronomy and begins watching the universe. Unlike most observatories, it does not spend weeks focused on a single galaxy or wait for one perfect photograph. Instead, it surveys enormous sections of the sky over and over again, searching for anything that changes. Every few nights, the Vera C. Rubin Observatory scans the entire visible southern sky. It looks for objects that have moved, stars that have brightened or faded, galaxies that suddenly flare with light, and mysterious points that appear where nothing existed before. Rather than creating a single snapshot of the cosmos, it is building an enormous time-lapse record of the universe itself. Even before its full scientific mission officially began, the observatory started revealing remarkable discoveries. Its first observations uncovered breathtaking images containing millions of distant galaxies, previously unseen rivers of stars stretching far beyond their host galaxies, thousands of new asteroids, unusually fast-spinning objects that challenge current theories, and visitors from other star systems passing silently through our cosmic neighborhood. Each discovery suggested that the night sky is far more active than astronomers once imagined. The Rubin Observatory was designed to create the most detailed survey of the changing universe ever attempted. Yet its earliest observations hinted at something even more extraordinary. They showed that the universe is constantly evolving, often in ways that happen too quickly for traditional telescopes to notice. Located on Cerro Pachón in northern Chile, the observatory takes advantage of exceptionally dry air, high altitude, and almost perfectly dark skies. These conditions allow it to collect enormous amounts of light with incredible clarity. Its main scientific program, known as the Legacy Survey of Space and Time, is not simply about taking beautiful photographs. Its goal is to record how the universe changes over an entire decade. Imagine recording a movie instead of taking a single picture. That is exactly what Rubin is doing. Every few nights it returns to the same regions of space, capturing fresh images and comparing them with previous ones. If an asteroid shifts across the background, if a star suddenly fades, if a distant galaxy erupts with energy, or if an entirely new object appears, the observatory immediately recognizes the difference. Each change generates an automated alert that is sent to astronomers around the world. During testing, the system produced hundreds of thousands of alerts in a single night. Once the survey reaches full capacity, that number is expected to climb into the millions every night, creating an unprecedented stream of discoveries waiting to be explored. This continuous monitoring is what makes Rubin fundamentally different from earlier observatories. The Hubble Space Telescope transformed astronomy by revealing extraordinary detail in distant objects. The James Webb Space Telescope expanded our view into the infrared universe, allowing scientists to observe some of the earliest galaxies ever formed. Rubin adds an entirely new dimension by revealing how the universe changes with time. For centuries, people believed the night sky was almost unchanging. The stars seemed fixed, the constellations appeared permanent, and distant galaxies looked frozen across the heavens. Human lifetimes were simply too short to witness the slow evolution of the cosmos. Rubin is proving that impression was incomplete. The sky is alive with constant activity. Asteroids race through the solar system. Massive stars reach the ends of their lives. Galaxies collide, stretch, and merge over immense periods of time. Occasionally, mysterious visitors from beyond our solar system pass through before disappearing forever. Many of these events remain invisible unless someone keeps watching the same places repeatedly. That is exactly what the Rubin Observatory was built to do. Instead of asking what exists in space, it asks a far more powerful question. What has changed since the last time we looked? The answer is already transforming astronomy. Every new observation adds another frame to an ever-growing movie of the universe, revealing motion, change, and hidden events that a single image could never capture. The first months of observations have already demonstrated how much has been happening above our heads without anyone noticing. What seemed like a quiet and unchanging universe is beginning to reveal itself as a dynamic, ever-changing cosmic landscape, filled with movement, transformation, and surprises waiting to emerge from the darkness. When the Rubin Observatory released its first collection of images, astronomers around the world were stunned by what they saw. One of the most remarkable photographs contained nearly 10 million galaxies packed into a single composite image. These were not individual stars scattered across our own galaxy, but entire island universes, each potentially containing billions of stars, countless planets, black holes, and mysteries that remain beyond our reach. And this breathtaking image represented only a tiny portion of the sky Rubin will eventually survey. Over the next decade, the observatory is expected to map billions of galaxies, creating one of the largest and most detailed records of the universe ever assembled. Hidden within those early observations was another extraordinary discovery. Astronomers identified a faint stellar stream extending roughly 163,000 light-years from the spiral galaxy Messier 61. The structure stretched even farther than the diameter of our own Milky Way, yet it had remained unnoticed until Rubin's powerful combination of wide-field imaging and exceptional sensitivity revealed it. These stellar streams are not simply beautiful formations. They are the remnants of ancient cosmic encounters. When a smaller galaxy or star cluster passes too close to a larger galaxy, gravity can slowly pull its stars away, stretching them into enormous rivers of light that drift through space for billions of years. These structures preserve the history of galactic collisions and provide valuable clues about how galaxies grow over time. Even more importantly, they help scientists trace the invisible influence of dark matter. Although dark matter cannot be seen directly, its gravity shapes the motion of stars within these streams. By carefully measuring their paths, astronomers can begin mapping the hidden mass surrounding galaxies. Rubin's early discoveries extended much closer to home as well. Before the observatory had even entered full scientific operations, it had already detected more than 11,000 previously unknown asteroids. For most telescopes, that would have been considered a career-defining achievement. For Rubin, it was only the beginning. Researchers expect the observatory to discover nearly 1 million new asteroids during its first full year of operation. That would rival the total number humanity has identified over the past 2 centuries, dramatically expanding our knowledge of the solar system in an incredibly short period.